Hello students, welcome to today's class. I am Bernisha, lecturer from Emmanuel College of Pharmacy. Today we are going to discuss about a topic from emulsion from the subject pharmaceutics, that is instability of emulsion and evaluation of emulsion. This topic helps in developing the knowledge about the causes of instability and the method used to evaluate emulsion, which are critical in the pharmaceutical formulation and quality control. Let's get into the video. In the last videos, we have learned about what is emulsion, what are the formulating agents we are used to prepare a stable emulsions, and what are the methods we are used to prepare a stable emulsion. In this video, we are going to study about the instability of emulsions. That means there is some of the deviation from the stability of the emulsions. Instability means nothing but there is a deviation from the ideal behavior of an emulsion. We know that each and every emulsion we have prepared should have some of their ideal behavior. When there is any deviation from that behavior, it is known to be instability. We know that when an emulsion is said to be stable, it should be remain as such when it is prepared. In what condition, whether this emulsion is prepared, it should be in that condition till it reaches the consumer or throughout their shelf life. For example, we know emulsion is a biphasic liquid dosage form in which one phase is dispersed as a globules in another phase. So that throughout their shelf life, the globules must be uniformly distributed throughout the dispersion medium. If there is any deviation in that conditions, it is known to be instability. But this instability is classified into certain conditions. They are certain phenomena. They are flocculation, coalescence, cracking or breaking, creaming, deterioration by microorganisms, physical and chemical changes. We can easily identify these differences by this picture. We can see the good emulsion shows that the dispersed globules are uniformly distributed throughout the dispersion mediums, but when there is a changes in their stability or there is some of the deviation from the ideal behavior, it may show some of their phenomena such as flocculation, breaking, creaming, coalescence, etc. Now let's see the detailed about these phenomena. First is flocculation. Flocculation is one of the instability phenomena in which the emulsion droplets are the dispersed globules which aggregates, thereby forming a larger units. When we see this picture, we can easily identify that in good emulsion, the dispersed globules are uniformly distributed all around the dispersion medium. But when it goes to the flocculation, we can see the dispersed globules are joined together or aggregated to form a larger units, so that each globules are joined together, but they won't become a larger globules, but they forms only a larger units by forming a connections. These larger units are called as flocks. So because of that means it is known to be flocculation. But this flocculation process is a very easy or weak reversible process. So that when some of the dispersible globules or dispersed globules are joined together to form a larger units, these larger units can be easily redispersed by shaking or by heavy agitation process. So it is a very weak reversible associations. We can easily reverse this process only by once by shaking or by agitation or by increasing the concentration of the emulsifiers. Emulsifier is nothing but the emulsifying agents which is used to mix both the phases. So this flocculation is means when the emulsion droplets aggregates or join together to form a larger units called as flocks, but it is a very weak reversible association of globules, so that it can be easily redispersed by shaking or by using the increasing the concentration of the emulsifying agents. Second one is coalescence. Coalescence is similar to that of flocculation. In flocculation, these small droplets join together to form a larger units. But in coalescence, the smaller droplets merge together to form a large droplet. When we see this picture, we can easily identify that the smaller droplets join together to form a large um, droplets. But it is a very irreversible process because the flocculation is a reversible process, but the coalescence is the irreversible process because in this process the large droplets are merged together and it forms a larger droplets, and these emulsifier film around the globules are destroyed to a certain extent because these droplets are joined together and it fully destroys the emulsifier films around the globules. These coalescence can be easily identified by seeing the increased size of the globules and the reduced number of globules. We can easily evaluate. We can easily identify this by the evaluation techniques when we are undergoing the counting of the globules or to checking the size of the globules and the number of globules. This can be prevented by using increasing the mechanical strength of the interfacial films. So we can prevent this by adding some of the emulsifying agent with higher mechanical strength or mechanical strength. So why this coalescence can occur? What are the reasons for this instability condition? Means there will be some of the insufficient amount of the emulsifying agents and altered partitioning of the emulsifying agent, or some of the incompatibilities between the emulsifying agent, because we have already studied that we will use both acacia and tragacanth in liquid paraffin emulsions. But like that, if you are adding some other emulsifying agent in that time, it may show some of the incompatibilities problems. During that times, we can identify these types of instability phenomenons. So coalescence is nothing but the smaller droplets merge together to form a larger droplet. So next is cracking or breaking. Cracking is nothing but the dispersed particles came together to form a large globule. That process is known as coalescence. In the last slide we have studied that the dispersed particles forms a larger globules. When there is a large time large time of forming these large globules, they may undergo the separation by two distinct layers. The emulsion may separated by two layers. So that first will be the larger globules, which is formed by joining the dispersed particles, and another layer will be the dispersion mediums. So when the coalescence phenomenon undergoes for a large time period, it may leads to cracking or breaking. It is a very irreversible process or a irreversible phenomenon. What will be the reasons for breaking? Means we are adding the emulsifying agent of opposite type, because if there is we have to use the HLB scale for selecting the emulsifying agent. But when we are for the oil in water emulsion, we have to add low HLB scale emulsifying agent. But when we are adding opposite to that, we will undergo this type of cracking phenomenon. Next one is decomposition or precipitation of emulsifying agent. Next, if we are adding the emulsifying agent, sometimes it may undergo precipitations. This means also leads to cracking. Next is based on the temperature, freezing conditions, and also by the addition of common solvent. Common solvent is nothing but the dispersion medium. So first is flocculation. Flocculation means the globules join together to form a larger units. Next, the dispersed globules form to becomes a larger globules, that is coalescence. When the coalescence undergoes for a large period of time, it may leads to cracking by separating it into two layers. These are the difference between these three phenomenons. Next is first we have already studied that what are the reasons behind the causes of breaking. First is addition of emulsifying agent of opposite type. So such as the soap of monovalent metals. These are some of the emulsifying agent which produces oil in water type of emulsions, whereas soap of divalent metals will produces water in oil type of emulsions. But when we are add this monovalent soap to a divalent soap emulsions, this may leads to cracking of emulsion. So that it is the addition of emulsifying agent of an opposite type. Next is decomposition or precipitation of emulsion. So we have already said that when we are adding an acid to an alkali soap emulsions, it may leads to precipitation of the emulsifying agent, because we are adding some of the acid to the alkali soap. When an acid reacts with the base, it forms a salt. So it may leads to some of the precipitation or decomposition of the emulsifying agent. For example, when sodium chloride is added to sodium or potassium soap, it may leads to the precipitation of emulsifying agent. This may further leads to the cracking of emulsion. Next is addition of common solvent. Addition of common solvent means when a solvent is added on to an emulsion, the solvent must be miscible or dissolve the emulsifying agent, because the dispersion medium is taken for dissolving the emulsifying agent. But when it does not undergoes or miscible or dissolves the emulsifying agent, it may leads to cracking. For example, the addition of alcohol to the turpentine element, which may leads to cracking. Next is microorganisms. Microorganisms, we have already known that the most prone disadvantages of this emulsion is it is more prone to the microorganism, because we are using the dispersion medium as aqueous or non-aqueous solutions. So due to the microbial contaminations, this emulsion may get deteriorate and may leads to this instability conditions. Next is change in temperature. When we store this emulsions in a large or high temperature, it may leads to decreasing the viscosity of the emulsions, because when there is a rise in temperature, it decreases the viscosity. So this may leads to creaming. But while storing it in the cold or freezed condition, it leads to formation of ice on dispersion medium, because it gets freezed. The dispersion medium gets freezed, so that it may leads to cracking. So when there is a rise in temperature also, it may leads to cracking. When we are storing it in a cool or freezed condition, it also leads to cracking. So the emulsion must be stored in a certain cool temperature. Next is creaming. Creaming is nothing but creaming emulsions, because cold creams or vanishing creams, these creams may easily undergo the rapid cracking conditions. Next is creaming process. Creaming may be defined as the upward movement of the dispersed globules to form a thick layer at the surface of the emulsions. So that if we taking when we are taking a account on a good emulsion, we have seen that the dispersed globules are distributed uniformly around the dispersion medium. But in creaming, the dispersed globules will move upward. Sometimes in creaming process, the dispersed globules move upwards and forms a thick layer. In this picture, we can easily identify that the globules get moves upward and forms a thick layer, or sometimes it may forms a thick layer at the bottom of the emulsion. It is a temporary phase. It can be easily redistributed by mild shaking or stirring with homogeneous emulsion. Stirring again to get, we can, if it is undergoes shaking or stirring process, we can easily get a homogeneous emulsion. It is a very just a temporary phase. But when it is a prolonged time, when the creaming process is around a prolonged time, it may leads to cracking or some with a complete separation of two phases. Already we have studied that cracking means separation between two phases. So when the creaming process undergoes for a long time period, it may leads to cracking process. The creaming condition is based on the Stokes law. We have already known that Stokes law is V is equal to 2 R square D1 minus D2 into G divided by 9 meter. Here V is nothing but the rate of creaming and R will be the radius of the globules, and D1 will be the density of the dispersed phase, and D2 will be the density of the dispersion medium, and G will be the gravitational constant, and eta will be the viscosity of the dispersion medium. Based on this Stokes law, we can easily identify how the creaming is affected, how the creaming happens. So then in this slide, we are going to see why creaming. By using this Stokes law, we can easily identify that radius of the globules. We can know that V is equal to R square. So as per the Stokes law, larger size of the globules, the rate of the creaming is faster. When the globules, the dispersed globules are in larger size, it is the inverse, directly proportional. So when the globule size increases, the rate of creaming also increases. So to prevent this, we have to reduce the size of the globules. Next is different density of the dispersed phase and continuous phase. We have already known that D1 minus D2. As per the Stokes law, once the density difference between the dispersed phase and the continuous phase increases, which may leads to the increase in creaming. When D1 minus D2 get increases, the creaming also increases. Next is viscosity of the medium. Viscosity is inversely proportional to the creaming. We know eta denotes the viscosity. It is inversely proportional to the creaming. When the viscosity increases, the creaming process decreases. When the viscosity decreases, the creaming process increases. So storage conditions. Storage conditions is nothing but the temperature. We have already known that through creaming means when cracking process, we have already studied that the rise in the temperature may leads to decreases in the viscosity, which increases the creaming process. So phase inversion. So next is phase inversion. Phase inversion means nothing but while during this instability conditions, the oil in water type emulsion may changes into the water in oil type emulsions. The water in oil type emulsion will changes to oil in water type emulsions. Why the phase inversion? What is the reason for this phase inversions? It may be leads by the addition of electrolytes. It may be by the addition of electrolytes or by changing the phase volume ratio. When we are changing the phase volume ratio, or by the change in temperature, or by some of the changes in the temperature, or changing the emulsifying agent, due to the changes in the temperature, due to the changes in the emulsifying agent, or changing the phase volume ratio, or by the addition of electrolytes, there will be the instability in the there will be the instability in the emulsions. That is phase inversion, in which the water in oil emulsion will changes into oil in water emulsion. Next is deterioration by microorganism. Deterioration by microorganism means when the emulsion is in unstable condition, that means the emulsion gets contaminated by the microorganisms, because most of the emulsions are very sensitive to the growth of bacteria, yeast and mold. Because we know the emulsifying agent we used in the formulation of emulsion is a very suitable media for the growth of microorganisms. So because of that, the emulsion may be very unstable because of the growth of these microorganisms. These microorganisms mainly contaminates our aqueous phase, and it also produces rancidity of the oil phase. Rancidity means that the oil becomes the oil's quality become very less, and there will be a very decreases in the chemical reactions, and thus it results in the differences, or thus results in the changes in the taste and odor of the oil. So the microorganism contamination mainly occurs in the aqueous phase, and also it produces the rancidity of the oil phase. In order to prevent this deterioration, we have to add some preservatives, because these preservatives mainly protect our emulsion from this instability by the microorganisms. Usually we add benzoic acid, salicylic acid as a preservatives through in the formulation of emulsions. In sometimes we may also add high concentration of alcoholic solution, which provides adequate protection against the microorganisms and help us to prepare a stable emulsion throughout their shelf life. Now let's see what are the causes for this deterioration. Mainly the decomposition of emulsifying agent. We already know that emulsifying agent is very suitable for the growth of microorganisms. So when there is any decomposition in that emulsifying agent, it may leads to the contamination by the microorganisms. Next, contamination of aqueous phase. We know during the preparation of emulsions there will be during the preparation of emulsion there will be the use of aqueous phase. We can use different types of water such as sterile waters, distilled water, deionized water. If there is any contamination by the impurities present in that water, it may lead to deterioration by the microorganisms. Next is produce rancidity of the oils. Mainly this microorganism causes the rancidity of the oils. It may due to the rancidity of the oils. That means we are using the less quality oils. Next is density oil soluble vitamins. Mainly the oil soluble vitamins density may change or causes this deterioration. Next is miscellaneous physical and chemical changes. Miscellaneous physical and chemical changes includes physical changes is nothing but temperature, light, oxidation, change in pH. These are some of the physical and chemical changes. We have already studied that temperature, how the temperature causes instability in emulsions. Nothing but when we are storing that emulsion in a high temperature room, it may leads to decreasing of the viscosity. When the viscosity decreases, it may leads to increasing the creaming, because according to the Stokes law, rising in the increases in the temperature is inversely proportional to the creaming. The temperature is inversely proportional to the creaming. So that when there is an increase in temperature, it will be when there is an increase in temperature, there will be a decrease in viscosity. When there is a decrease in viscosity, there will be increase in creaming. Next is deterioration of light. Like some of the chemicals or some of the active ingredients we are used for the preparation of emulsions or light sensitive materials. But when we expose that substances or that emulsion towards the light, it may leads to deteriorations. Next is oxidative and hydraulic rancidity of the oil. Oxidation is nothing but it is a process or a chemical process in which um, the active ingredients or a emulsifying agent in that emulsion undergoes oxidation process. Next is rancidity. Rancidity is nothing but the oil present in the emulsion phase. The oil phase present in the emulsion reduces its quality, and there will be some of the changes, and they undergoes decomposition in their chemical reactions, and which may leads to bad odor, or there will be changes in the taste, and it further reduces the quality of the oil. And next is change in pH. When we are adding some of the acid towards the emulsion, it may mismatches or changes the pH. Due to the changes in the pH, there will be the chances of producing some of the instability. So we have, what are the things we can maintain to avoid these chemical changes? First, we have to protect the emulsion against deterioration by light, extreme temperature, oxidative and hydraulic rancidity of the oils. We can easily prevent, because we know that rise in the temperature will increase the creaming process. So we have to protect the emulsion in a, or we have to keep the emulsion in a cool place and to maintain the temperature throughout their shelf life. Next is deterioration of light. We can easily prevent the light sensitive materials by keeping the emulsion in an amber color bottles, or keeping it in a well closed container inside the cupboard or something like that. And next is oxidative and hydrolytic acidity of an oil can be easily maintained by adding some of the antioxidants. And the next is change in pH can be maintained by using buffering agents. Next is freezing and thawing result in coarsening of globules, sometimes breaking emulsions. So we have already know rise in temperature will decreases the viscosity. Likewise, when the temperature also get high, or when the temperature is very low and it reaches the freezing point, the dispersion medium get freezed, so that it may leads to rough and coarsening globules, so that it may leads to breaking of emulsions. So we have to maintain a certain temperature, not a high temperature or a very low temperature. We have to maintain a balanced temperature throughout the shelf life of the emulsion. Next is light and transitivity, which influences the color and odor of some of the oils, which also destroys the vitamin activity of the oils. And the emulsion should be kept in a tight container and stored at a moderate temperature, so that it can be maintained, or which can be easily protected from the light and other temperature conditions. Next, we are going to study about the theory of emulsification. Theory of emulsification means we are using some of the theories to understand the conditions of emulsification process. Mainly, we uses four theories, that is film theory, viscosity theory, wedge theory, and interfacial tension theory. These are the four theories which is mainly involved in the emulsification process. Emulsification is nothing but the mixing of two phases, that is, one is dispersed phase and another one is the dispersion medium, with the help of emulsifying agents. First theory is film theory. This theory is also known as adsorption theory. Adsorption occurs in the surface of the absorption occurs at the surface of the globules. So based on this theory, when we are adding the emulsifying agent, it forms a mechanical film around the globules. It forms a mechanical film around the globules, and by getting absorption at the interface of the liquids, and it gets absorbed at the interface of the liquids, which offers stability to the emulsions. That is, when we are adding the emulsifying agent, it forms a mechanical film and it gets adsorbed to the interface of the liquids. Thus, it offers stability of the emulsions. But these theories have some limitations. That is, this theory could not explain the formation of type of emulsions. It does not explain the formation of the which type of emulsion is formed. Next is viscosity theory. Viscosity theory means, in this theory, we have to increase the viscosity of the emulsions. By increasing the viscosity of the emulsions, which leads to the increasing of the stability of the emulsion. We have already studied that as per the Stokes law, when the viscosity decreases, the creaming increases. So when we increases the viscosity of the emulsion, it leads to the preparation of increases the stability of the emulsions. But this theory also has some limitation. That means it fails to explain about the milk, which shows the considerable stability, but the viscosity of the milk is very less. Though the viscosity is very less, it shows the considerable stability. So viscosity theory is nothing but when by increasing the viscosity of the emulsion, which leads to the increase in stability. Next is wedge theory. According to this theory, when the monovalent soap like sodium stearate, it gives oil in water type emulsions, and the divalent soap like calcium stearate gives water in oil type emulsions. This theory, which explained by successful accommodation of the soap molecules, which give the type of emulsions. With the help of the soap molecules, we can easily identify the type of the formed emulsions. Which type of emulsion is formed? With the help of the soaps, we can easily identify the type of emulsions. This is Wedge theory. According to this theory, the monovalent soap will forms oil in water type emulsions, and the divalent soap like will form water in oil type emulsion. Next theory is interfacial tension theory. Interfacial tension theory means it is the tension between the two phases. That means between the dispersed phase and the dispersion medium. Based on this theory, when we added an emulsifying agent, it reduces the interfacial tension between the oil and water phases, because already we know that interfacial tension means it is the tension between the two phases, that is dispersed phase and the dispersion medium. While adding the emulsifying agent, it reduces the interfacial tension between the two phases, and thus helps in the mixing of two phases or emulsifying of two phases, and helps us to form a stable emulsions. But however, this theory could not explain the formation or the type of emulsions. So these are the four types of theories which is used in the process of emulsification. First is viscosity theory, width theory, interfacial tension theory, and film theory or adsorption theory. Next is evaluation of emulsions. So these are the some of the instability problems. What are the instability problems? We have learned is flocculation, coalescence, creaming, cracking, deterioration by microorganism, miscellaneous chemical and physical changes. These are the six main important, including case inversion. These are the seven instability problems of emulsions. Next is evaluation of emulsions. Evaluation of emulsion is nothing but when we are preparing an emulsion, or when the preparation process is fully completed, we have to evaluate or check the quality of an emulsion. That is known as evaluation of emulsions. So we have to check whether the emulsion is in good quality, or it can withstand all their shelf life period. So whether there is any instability problems before dispatching it to the marketing side, we have to fully check the quality of the emulsion. That process is known as evaluation of emulsion, checking the quality of emulsion before it reaches the consumer or before it gets marketing. So how we can check check the quality of emulsions? First is by the determination of particle size and particle count, because we have already known that the particle size of the globules plays the major role in the stability of emulsions. When there is when there is the changes in the size of the globules or count of the globules, it may lead to some of the instability problems such as coalescence. So determination of the changes in the average particle size and the size distribution of the droplets, which is a very important parameter for the evaluation of emulsions. When there is a when there is an deviation from the standard values, the emulsion has to be rejected. This evaluation, the particle size evaluation and particle count, can be performed by using optical microscopy, and sedimentation by using Anderson apparatus and culture counter method. First is optical microscopy is nothing but we have to take a emulsion and we have to check it in the microscope and count the globules and count the particle count. Based on the average particle count, we can easily identify whether the emulsion is stable or whether it is affected by some of the instability conditions or phenomenon. Next is determination of viscosity. Viscosity plays an important role in emulsion stability. When there is a decrease in viscosity, the creaming gets increases, so that there will be the emulsion gets inverse. There will be the separation of phases. So the viscosity has to be checked during the evaluation of emulsions. This emulsion exhibits mainly non-Newtonian type of flow characteristics. So this type of viscosity can be determined by using the viscometers. They have you mainly includes the cone and plate viscometers. Mainly the Brooksfield viscometers are used for the evaluation of viscosity, because the emulsion exhibits non-Newtonian type of flows. For that, first we have to measure the torque required to rotate the spindle in the liquids. The principle for this Brooksfield viscometer is the torque required to rotate the spindle in the liquid. For the procedure, first we have to immerse the spindle in the sample and we have to set the speed. The instrument gives the direct viscosity reading of the emulsions. Within that reading, we can easily identify whether the emulsion is in stable condition or there is some of the instability problems. Mainly, the emulsions are determined or evaluated using Brookfield viscometer as it exhibits the non-Newtonian type of. The third one is determination of phase separation. The phase separation is refers to the breaking of emulsion into two distinct layers, that is the oil and water. So it is very another parameter used for assessing the stability of the formulations. It can be evaluated by visual observations. First, the emulsion is kept in a graduated cylinder or a bottle, and we have to regularly check that whether there is any stability problems, instability problems, or there is some of any formation of separate layers, or there is a creaming or cracking or any other phenomena undergoes. So determination of phase separation, first we have to check it or evaluate it by using the visual observation method. And the next is by using centrifugation methods. When we are actually we have to separate this oil and water by centrifugation, and during the centrifugation process we can easily identify the layer formation of the emulsions. Next is by measuring the creaming index. Through measuring the creaming index also we can easily identify the phase separation evaluation. Through thermal testing or stress testing also we can identify the phase separation process. So this phase separation is mainly used to assessing the stability of the two phases of the emulsion, so that mainly they are observed by visually. Usually we are using visually only we are determining or evaluating the emulsion techniques. For that, first we have to keep that emulsion in a graduated cylinder or a separate bottles, and we have to check it in a common intervals. We have to check it in a regular intervals, so that through that we can easily identify whether it may undergoes any of the instability phenomenons. And the next is determination of electrophorotic properties. Electrophorotic properties is nothing but the movement of emulsion droplets under the electric fields, which indicates the surface charge of the droplets. Usually, the surface charge can be expressed as the theta potential. When we are applying an electric field, we have to check or evaluate the movement of emulsion droplets under an electric field. The theta potential. When we are evaluating the theta potential, we can easily assess the stability of an. For that, first we have to take the emulsion sample in a theta potential analyzer or an electrophoresis cell. For that, next we have to apply an electric field towards the sample. Next we have to check or observe the movement of droplets using a microscope or an instrument used to observe this movement of emulsion, movement of dispersed globules. Next we have to measure the velocity of droplets. How much speed does that globules moves from one place to another. Next we have to calculate the theta potentials. By calculate the theta potential, we can easily interpretate or assessing the stability of emulsions. When there is a high theta potential, there will be strong repulsion and it may lead to stable emulsions. When there is a less theta potential, it may undergo weak repulsion, so there will be an aggression and it leads to instability. So first we have to apply an electric field and we have to observe the movement of globules. Through that we have to calculate the velocity, and after that with the help of that velocity we can easily calculate the theta potential. When there is a high theta potential, there will be strong repulsion. Strong repulsion means they won't get aggregate with each other, or they won't join with each other. The globules won't join with or merge with each other. So it will be stable emulsion. or but when there is a low zeta potential, it may lead to weak repulsion, and it means it will be an aggression state, and there it may lead to instability. So these are the four common evaluation techniques. First is determination by the particle size and particle count. Next is determination of viscosity, and determination of phase separation, and determination of electrophoretic properties. These are the main four evaluation techniques used to determine or evaluate the stability of emulsions. Next is labeling of emulsion. Usually the container the label container emulsion container contains a label shake well before use, because sometimes the droplets may settle upwards or downwards. To get the dose uniformity, we have to give an information to the patients like shake well before use. Next, we have to see the containers, how we are storing the emulsions, and what are the containers we are used for the storage of emulsions. The emulsion should be packed in a container which should have an adequate airspace above the emulsion, so that we can easily permit the adequate shaking before it used, because the emulsion contains the label of shake well before use. We have to give some airspace before above the emulsion inside the bottle. Next is the emulsion which is used to mean for the internal use should be packed in comparatively wide mouth bottle, so that we can easily consume it without any difficulties. So metallic closure should be avoided. So mainly we have to avoid the metallic closure. Next, wide mouth amber glass bottle are most suitable for emulsion storage of emulsion. Wide mouth amber glass bottle, because some of the active ingredients may be light sensitive, so we have to use amber color bottles. Next is storage conditions. First, we have to store it in a airtight container. We have to protect it from the sunlight or freezing and high temperature. Next, the emulsions are required to be stored in a cool place, not in a high temperature or in a low temperature. It should be stored in a very cool place. These are some of the points we have to noted before storing a stable emulsion. Okay students, I hope in this video we have learned about the instability problems of the emulsions, and also the evaluation techniques used to analyze the stability of the emulsions, and some of the points we have to note while storing the emulsions. Let's see some small recap for the instability and the evaluation techniques of emulsions. First is the instability problems of emulsions. Instability is nothing but the deviation from the ideal behavior of the emulsions. There may be seven phenomena. They are flocculation, coalescence, creaming, cracking, phase inversion, mixed deterioration by the microorganisms, and miscellaneous physical and chemical changes. When flocculation is nothing but the small droplets, the globules, join together to form units, so to form a large units, so that it is very reversible. We can easily reversible it by stirring or agitation process. Next is coalescence. Coalescence is nothing but the droplets are joined together to form a larger globules. It is an irreversible process. We cannot easily irreversible this emulsion. Next is creaming. Creaming is nothing but the coalescence. When the coalescence undergoes for a prolonged period, it may move upward direction, so it is known as creaming. When the creaming is taken for a large time, it may lead to cracking, so that there will be a separation of two phases, and the globules will form a separate phase. It is also an irreversible instability problems. And the next is phase inversion. In this, the water in oil emulsion will be converted into oil in water emulsion, and the oil in water emulsion will be changed into water in oil emulsion. Next is deterioration by the microorganism. This type of instability problems can be affected by the contamination of microorganisms. And the next one is miscellaneous physical and chemical changes. Miscellaneous physical and chemical changes includes the physical changes includes temperature, next light or pH changes, or by the chemical processes such as oxidation or hydrolytic rancidity of the oil phases. These are the instability problems which mainly affects the stability of an emulsion. And the next one is evaluation of the emulsions. The evaluation of the emulsions is nothing but how we have to check the quality of the emulsions we have prepared through four techniques. They are determination by their particle size and particle count. This can be done by counting their particles and the globule size. Next one is the determination of viscosity, which is used to determine the viscosity mainly by using the Brookfield viscometer. And the next one is determination of what is the next one? The determination of electrophoretic properties. Electrophoretic properties is nothing but the determination of theta potential of an emulsifying droplets. And the final one is determination of phase separation. It is also used to determine the two phases, that is the liquid phase and also an oil phase, and within that we can easily assess the stability of an emulsion. These are the four evaluation techniques we are used to for the used to check the quality of an emulsion. So, okay students, I hope we all have learned thoroughly about the instability problems of the emulsion and the determination techniques uh, or the evaluation of emulsions, and some of the techniques we have, some of the points we have to note during the storage of emulsions. I hope this video will be very useful for your emulsion topics. Let's see in the next video. Thank you.